Good morning, students. Last class I have finished the problems on different types of functions, like we have finished one function problems and onto function problems. Especially I told the function f of x is equal to x square is defined on f maps from R to R and f maps from Z to Z and f maps from n to n. R to R means real numbers to real numbers. Z to Z means set of all integers to set of all integers. N to n means set of all natural numbers to set of all natural numbers. Like that, on all these set of all numbers, we have finished the problem f of x equal to x square. And for this function, in which case it forms 1 and in which case it is not 1 function, and which case f is forms onto, and in which case f is not becomes onto. For all these we discussed about all this. Next, even I told two different types of names also for these two functions. And one function is also called as injectivity function, and onto function is also called as surjectivity function. And today also we will solve problems on these two functions only. Now, first question is, check the injectivity or surjectivity. Check the injectivity and surjectivity. Check the injectivity and surjectivity for the following functions. For the following functions. For the following functions. First question is, f maps from n to n. F maps from n to n is given by f of x is equal to x cube. F of x is equal to x cube here. So this function is 1 or onto. How to check about this? Solution for this question is, let the given function f of x is equal to x cube. X cube is defined on f maps from n to n. Let us now, we are going to checking f is 1 or onto. First, how to check about this, is it 1 or not? First one is the 1 function. 1 function. F of x1 is equal to f of x2. F of x is x cube, then f of x1 becomes x1 whole cube, becomes f of x2 becomes x2 whole cube, x2 cube. For these two terms, equality symbol is there. At the same time, they have same powers. That's what directly we can equate there. X1 is equal to x2. Therefore, we can write f is a 1 function. F is a 1 function. If we can get procedure like this, easily we can tell about this. Different elements of domain capital N is associated with different elements of codomain capital N. How means I will show now by diagrammatically now. See here. say here, it is let of all real numbers, natural numbers. It is set of all natural numbers, n to n mapping 1 2 3 4 5 6 7 8 9 10 up to and so on, like this. 1 2 3 4 5 6 7 8 9 10 27 64 125, like these numbers. It is x, it is the y is equal to x cube, because f of x equal to x cube they gave here. It is the x, it is the x cube. X is equal to 1, then y is equal to 1 cube, 1 to 1. X is equal to 2, then y is equal to 2 cube, 8. X cube is equal to 3, then y is equal to 2 cube means 27. X is equal to 4, then 4 cube means 64. Like that. 5, 6, 2, 6, like this. Different elements and different images. That's what easily we can tell. It is f is a 1 function. That's what before that I mentioned here, f of x1 is equal to f of x2. On solving those equation, finally we got x1 is equal to x2. If we can get like that, means we can tell about that different elements of domain capital N are associated with different elements of codomain capital N. Now therefore f is 1 function. For that already we proved also. Let us now, we are going to checking onto function. Onto function. Onto function. Onto function formula is f of x equal to y. F of x equal to y, it's a common. F of x plus is x cube, they gave given function. What is the given function they gave here? F of x equal to x cube here. That is x cube is equal to y, or x equal to cube root of y, because these types of numbers they are not belongs to capital N. Even when you are going to checking 1 means move from domain to codomain. When you are going to moving to check onto function means move from codomain to domain. Codomain to domain means all the elements of codomain they have association with the elements of domain A or not. See here, if you can observe some numbers 2, 3, 4, 5, 6, 7, 9, 10, like those numbers, they did not associate with any element of domain capital N. That's why easily we can tell that codomain is not equal to range. Codomain means whole sets. This whole set is called codomain. Range means only set of all images. What are the images here? 1, 8, 27, 64, 125. Like those numbers we are calling images. But image is only 1, 8, 27, 64, 125. But codomain is whole set. Can you equate them, these two sets? Can't. We can't equate these two sets. That's what we can tell. Codomain is not equal to range. That's what we can say f is not an onto function. Otherwise, you can write in words also like this. Mapping is not association with any element. With that element we can take as example. My wish, I am going to taking y is equal to 3. But as your wish, we can take any element that should not associate with any element of domain capital N. According to that, we must turn to select that element here. My wish, I am going to selecting that element is 3 only here. Let y is equal to 3. Let y is equal to 3 belongs to codomain N. Codomain N do not have any pre-image in the domain capital N. Therefore, f is a not onto function. One element enough. No need of checking all this. One element enough. At least one element enough. Example. To give an example, at least one element enough. You can select 4, 6, 7, 10, 11 or 28, 29. You can check any element. But that is not associated with any element of domain capital N. That element I have to select here. That's what I have selected 3 here. 3 does not map with any element of domain capital N. No. That's what 3 is the some of the suitable number for this example. You can take 7 also. 7 are suitable number for this example. That's what easily we can tell. F is not an onto function. Therefore, we proved f is one function. Therefore, we can write f is only one function. Only one function. Only one function, but not an onto function. Not an onto function. Not an onto function. Next, one more example. One more question. Let f maps from Z to Z. Second question. Let f maps from Z to Z is given by f of x equal to x cube. F of x is equal to x cube. Is it 1 or onto? Check about this. See, diagrammatically first you have to check this. It is Z. Here also Z's. Z to Z is F. Numbers 0, 1, 2, 3, 4, 5, 6, like this. -1, -2, -3, -4, -5, -6. Here is 0, 1, 2, 3, 4, 5, 6, 7, 8, up to and so on 27, like this. Here also -1, -2, -3, -4, -8, -27, up to and so on, like this. It is x. It is the y is equal to x cube. This is 0, 0 cube to 0 to 0. 1 cube is 1. -1, -1 cube is -1. 2 cube is 8. -2 whole cube is -8. 3 2 is 27. -3 is -27. Like the different elements, all, if you can move like this, mapping is finishing from all these elements. At the same time, different elements and different images. Already I told now, if you want to check 1 means move from domain to. Move from domain. For on to move from codomain. Now let us we are discussing about 1 only. For 1 means move from domain here. All the different elements, they have different images in domain Z. That's what easily we can say this f is a 1 function. Like that we can give solution for this question. Solution. Let the given function let the given function f of x is equal to x cube is defined on f maps from z to z. First one is 1 function. 1 function. f of x1 is equal to f of x2. f of x1 means x1 cube is equal to x2 cube. Directly we can write x1 is equal to x2. If we can get procedure like this, f is 1 function. Otherwise, for that you may raise doubt in these two steps. For that only I have shown the procedure for 1 is with help of diagrammatic representation here. Therefore, f is 1 function. Like this. Now we are going to giving proof for onto function. Is it forms onto or not here? Onto function. Onto function. Onto function formula is f of x equal to y, that is x cube is equal to y, that is x equal to cube root of y does not belongs to z. Here I showed diagrammatically here, no, before that only mapped with 1 8 minus 1 minus 8, because 3 and minus 3 2 and minus 2 they are not mapped with any element of domain capital Z. That's what you can take an element. My wish I am going taking y is equal to 3 here. Let's y is equal to 3 belongs to codomain Z. Codomain Z do not have any preimage in the domain Z. Therefore, f is not an onto function. F is not an onto function. Therefore, f is only 1 function. 1 function, but not an onto function. Like that we proved 2 questions. F of x equal to x square, f of x equal to x cube is defined on f maps from n to n, and f of x equal to x cube is mapped from z to z. In case of these 2 functions, f is only 1 but not an onto function. Next question. Prove that the signum function. Third question is prove that the signum function prove that the signum function is neither 1 1 nor onto. Neither 1 1 and nor onto functions. And nor onto functions. Onto functions. That is neither 1 1 nor onto functions here. Now let us, we are going to checking about this. Is it forming 1 1 or not? It is forming onto or not. First, before that, we must know about the definition of a signum function. That's what, when you are going to giving solution for this question is, first you have to given definition of signum function. See this solution for this question is, f of x equal to signum function, f of x equal to modulus of x dividing by x if x is not equal to 0. Exact 0 if x equal to 0 here. That is f of x equal to plus x by x one value is equal to, gets cancelled, is equal to 1. For this if x is greater than 0. Exact 0 if x equal to 0. Minus x by x on gets cancellations, will get minus 1 if x is less than 0. These are the values for 1, minus 1, 0 is the range of this. But it is matched from R to R only. All this f of x equal to matched from R to R only, real number to real number. Actual definition is, let the given function f maps from R to R is given by f of x is equal to modulus of x whole dividing by x if x is not equal to 0. 0 if x is equal to 0. It is the actual definition for the signum function. It is the actual definition for signum function. But all these are all real valued functions. These are all real valued functions means, when we are calling like those functions are real valued functions means, domain, codomain and range is the set of all real numbers. When domain, codomain, set of all real numbers means, then those types of functions must and should called as real valued functions. That's what this function is. F maps from R to R is given by f of x equal to modulus of x whole dividing by x if x is not equal to 0. 0 if x is equal to 0. On this modification of this function, will get this minus 1, 0, 1. Because here modulus is there now. If you can remove modulus, it gives two meanings, plus or minus. That's what here for modulus I have written one time plus and I have written second time minus. And middle value is 0. In definition only we got that if x is equal to 0, then definitely function value is 0. That's what here corresponding to x is equal to 0. We define 0 here. This is the definition of a signum function. Because with help of this definition only, we are going to showing is it 1 1 or not 2, or is it onto or not to. See here. Diagram representation. It's the real numbers. Here also real numbers. R2 are defined here. function 0, 1, 2, 3, 4, 5, 6 up to and so on, minus 1, minus 2, minus 4, minus 12 like this. 0, 1, 2, 3, 4, 5, 6, 7 like this. Minus 1, minus 2, minus 3, 4, minus 6. Already I told this in signum function. F of x is equal to, already I gave now, it is plus 1 if x is greater than 0. 0 if x is equal to 0. Minus 1 if x is less than 0. 0 means exact 0. Greater than 0. For 1 is the function value for all positive values. 1 is the function value for all positive values. 3 greater to 4 to 1, 5 to 6, 6 to 1 like this. For all x is greater than 0, for all positive real numbers of domain, 1 is the function value in codomain capital R. Next, move to minus 1. For all negative values of domain capital R, minus 1 is the function value. That's what here, different elements they have same as in 1, same as 1 in codomain capital R. That's what easily we can say that f is not an onto function, not 1 function. So 1 is 1 function. F of 1 is equal to, f of 2 is equal to, f of 3 is equal to, up to and so on is equal to plus 1. Or f of minus 1 is equal to, f of minus 2 is equal to, f of minus 3 is equal to, up to and is equal to minus 1. In words, the different elements of domain, the different elements of domain capital R, they have same image, same image 1 in codomain capital R. Therefore, f is not 1 function. See here, for all positive numbers we have same image 1. For all negative numbers we have same image minus 1. That's what easily we can say that f is not 1 function. Come to onto. See here, if you can observe this diagrammatic representation, the mapping is only 1, 0, minus 1, because range of signum function is 1, 0, minus 1 or minus 1, 0, 1. But codomain is whole set of all real numbers. That's what easily we can say that codomain is equal to range. Thus, f is not an onto function. When equality of codomain and range, if you can see equality of codomain and range in any function, then only we are saying that function f is an onto function, that is surjective function. But here, by observing the representation of diagrammatic text here, codomain is not equal to range. Codomain is set of all real numbers, range is minus 1, 0, 1. That's what easily we can say f is not an onto function. Only range like this, it is the range. Total, it is the codomain. But range is not equal to codomain. Therefore, clearly in case of signum function, in case in case of signum function, range is not equal to codomain. Therefore, f is not an onto function. Not an onto function. That's what we proved. F is not 1 1 and we proved f is not an onto function. That's what easily we can tell f is neither 1 1 nor onto, because diagram, by observing diagram representation, set of all positive real numbers function value is 1, set of all negative numbers function value is -1, exact 0 to 0. That's what different elements of domain, that is distinct elements of domain capital R, they have same image 1 in the codomain capital R. Even set of all negative numbers also, they have same image -1 in the codomain capital R. That's what we can say f is not 1 1 function or f is not injectivity function. Even in case of surjectivity also, that is in case of onto also, in case of diagram, if you can observe, codomain is whole set of all real numbers, whole sets capital R, but range is -1 0 and 1, because they are not matched, they are not equal. If they are not equal means f is not an onto function. Like that, today we proved 3 questions. F of x equal to x square is defined on 2 sets, f maps from n to n and f maps from z to z. At the same time, we discussed about signum function also. Next class we will discuss about greatest integer function and modulus function. Along with that, we will solve some different types of questions on 1 1 and onto functions only. Thank you very much.